Hi everyone, I hope you are doing well. Welcome to this video and welcome to my channel. In this video, we are going to learn how to calculate greatest common factor of two numbers or something which we call the GCF. In fact, by the end of this video, you will be able to solve these examples. Before I start solving examples, it's important to get familiar with the definition of factor. If I have two numbers and if I multiply them together and I produce the third number, the first two numbers will be factors of the third number. I know that this definition is a little bit challenging, but you are going to learn that through examples. Let's solve some examples with each other. The first example is 10, and I want to write factors of 10. Do I have any two numbers that if I multiply them together, the result will be 10? Yes. The first two numbers that I can guess is 1 and 10. So we are going to always start from 1 and the number itself. What else? Do I know any other two numbers? Yes, 2 and 5, because if I multiply 2 and 5, the result will be 10. So these numbers are factors of 10. What about 28? As I told you, we always start with 1 and the number itself, which in this case it is 28. What else? Do I know any other pair? Yes, 2 and 14. What else? Yes, I know 4 and 7. Do I know any other numbers? No, so these are factors of 28. The first method for calculating GCF, the first method that I'm going to introduce you is factor listing. This is really basic method. Sometimes it is really time consuming and sometimes the possibility of making mistake is really high. So when do we use this method? If you are in the elementary school, yes, you can use this method. If you are in higher levels, if you have two small numbers, it would be rational to use this method, but I do not suggest you. So let's learn this method with each other. What should we do? We must write all the factors of two numbers. Then we must choose the greatest common factor between those two numbers. Okay, let's solve examples with each other and we are going to learn that through examples. I want to calculate GCF of 9 and 12. So first, I must write factors of 9 and 12. As I told you, always start with 1 and the number. Do I know any other number that if I multiply them together, the answer will be 9? Yes, 3 times 3 will be 9. But because 3 is repetitive, I write it only one time. What about 12? Yes, I know 1 and 12, as I told you, we have it all always. And do you know any other number? Of course, 2 and 6. What else? Yes, 3 and 4. What else? Do I know any other number? No. Can you see anything common between these factors? Yes, 1 is common between 9 and 12, and 3 is common between 9 and 12. So which one is the greatest common factor or GCF? Of course, 3 is the greatest. Next example, GCF of 14 and 21 with factor listing. So I'm going to write 14 and I'm going to write 21 and I want to write the factors always start with 1 and the number, in this case it is 14. Do you know any other numbers? Yes, 2 times 7 will be 14. So 2 and 7. What else? No, I do not know anything else. What about 21? Always start with 1 and the number 21. What else? I know 3 and 7. What else? No, I do not know any other number, but you can check it. Can you see anything common between them? Yes, 1 is common between them and 7 is common between them too. So which one is the greatest? In this case, GCF is 7. Okay, as you can guess, this method can be really time consuming when you have a large number. For example, when you have 120, it would be really hard to write all the factors. So in that case, we are going to use another method which we call it prime factorization method. but it is really important to know how to calculate prime factorization of two numbers, because I'm not going to explain it. I have already taught you, and I'm going to put the link in the description. Before watching this part, stop the video and watch that video first, because otherwise you cannot learn this method. In this case, what should I do? First, I must write prime factorization of each number. Then GCF is equal to multiplication of common prime factors with the smallest exponent. It can be a little bit challenging for you or difficult for you, but you are going to learn that through examples. If two numbers have no common prime factor, the GCF will be 1. Okay, I told you first, you must watch the video how to calculate prime factorization of two numbers, and the link is in the description. Okay, I want to calculate GCF of 24 and 36. I start with 24 and I want to write prime factorization of 24. So I'm going to start with 2. If I divide it by 2, the answer will be 12. If I divide by 2, the answer will be 6. If I divide by 3, the answer will be 2. And 2, 1. And I'm going to write for 36. So I can divide it by 2. The answer will be 18. I can divide it by 2. The answer will be 9. I can divide by 3. 3. 3, 1. When I reach 1, I must stop. So for 24, I have 2 and 3. How many 2's do I have? 1, 2, 3. So 2 to the power of 3 times 3. And for 36, I have 2 and 3 again, but this time 2 to the power of 2. I'm sorry, 2 to the power of 2 times 3 to the power of 2. I told you, how can I calculate GCF? First, I must specify, do I have any common prime factors between them or not? Yes, both of them share 2 and 3. I can see 2 and 3 for 26, and I can see 2 and 3 for 24. So, common fact, GCF will be 2, 2 with the smallest power. Here, the power of 2 is 2, and here the power of 2 is 3. So, which one is the smallest one? Of course, 2. And for 3, I have 2 here, and I have 1 here. Which one is the smallest one? Of course, 1. So, GCF is equal to 2 to the power of 2 is 4 times 3. The answer will be 12. As you can see, this method is much more easier. Now we want to calculate GCF of 120 and 72. For 120, because there is a 0 at the end of the number, last digit, I can write 2 and 5. Then I can drop the 0 and I'm going to have 12. I can divide it by 2. I'm going to have 6. I can divide it by 2. I'm going to have 3. 3, 1. When I reach 1, I can stop. For 72, I can start with 2. I'm going to have 36, 2, 18, 2, 9, 3, 3, 3, 1. When I reach 1, I must stop. So I can write 120 as, how many 2's do I have? 3. So 2 to the power of 3 times, how many 5's? 1. How many 3's? 1. What about 72? How many 2's do I have? 2 to the power of 3. How many 3's? 3 to the power of 2. Let's calculate GCF with each other. I told you common factors. As you can see, in 72 I have 2 and 3. And in 120 I have 2 and 3 too. What about 5? No, you cannot see any 5 in the 72. So we should not consider that in calculating GCF. So the first common one is 2. The power of 2 here is 3, and the power of 2 is here is 3 too. So which one is the smallest one? There's no small, both of them are equal. So I write 3. What about 3? The power of 3 here is 2 and the power of 3 here is 1. So which one is the smallest one? Of course, 1. So GCF is equal to 8 times 3, which is 24. Let's calculate the GCF of 25 and 29. Let's start with 25 and find prime factors of 25. I can divide it by 5. I'm going to have 5. Again, 5, 1. When I reach 1, I must stop. I have 29. Do you know any prime number that I can divide 29 to that? Yes, of course. 29 itself, because 29 is prime. So I can write 25 as, and 29 as 29. Okay, let's calculate GCF. Can you see anything? Any factor which is common between them? No, here I have 29, but here I have 5. So I cannot see any prime common factor. So what is the GCF? In this case, I told you, in this case, GCF is 1. Okay, here I want to tell you what is the function of GCF. Why should we calculate GCF? It has several functions. I'm going to mention 2 of them. First, in an exam, for example, you may reach to the answer of a fraction, for example, 8 over 12. And this answer may be correct, but when you see the result, you realize that I have lost some points. What is the reason of that? Because you have not written the simplest form of the fraction. Okay, when I want to write the simplest form of the fraction, I must divide both numerator and denominator to GCF. You can calculate GCF of 8 and 12 with both of the methods, for example, listing factor or prime factorization method, and you will realize that GCF of 8 and 12 will be 4. So if I divide 8 and 12 by 4, this is going to be 2 and this is going to be 3. So the simplest form will be 2 over 3. And you can use it for factorization and algebra. You are going to learn that in higher grades, for example, grade 9 or something like that. If you have something like 3x plus 9, you can factor 3 and you are going to have x plus 3. And this method can be really, really useful, and we are going to use that for several functions. Here you can find more examples, and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, you know what to do. Write your question or your answer in the comment box, and I will try to answer them as soon as it was possible for me. Thank you for watching this video.